All right, guys, section 3.3, properties of logarithms. I'm hopeful that a lot of what we talk about today sounds familiar, but again, I'm sure that we're going to see some new things sprinkled in. We're going to see some new tactics along the way. So if you do not have a calculator out yet, please get a calculator out. If you need to borrow one, come on up here and borrow one. That'd be great. But again, the exact wrong way to handle today would be to just sit there and let everybody else do the calculations for you. Again, sure, you'll be able to have some numbers that you could write down on your note sheet. That's great. That'll be helpful. But what we definitely want to avoid is you sitting here, we do countless examples in class the rest of the way, and you feel like, yeah, I know how to do this. This is a piece of cake. And then you get home tonight to do your assignment, and we don't, our numbers aren't matching. Or even worse, we show up on Friday to take our quiz, and that's when we figure out, I don't really know how to type this into a calculator. So again, we definitely need to make sure, excuse me, that the calculations that you're doing, the way you're typing them in, that they are matching and getting leading to correct answers. All right. So again, if you need to borrow one, come on up and borrow one. Friday's quiz is going to be a no graphing calculator, and I know that stinks. Well, I'll put it this way: we're gonna have a plan to where you can use your graphing calculator for part, but not everything. Okay. Because there's an absolute graphing portion, which I can't let you use the graphing calculator on the graphing part. But there are also buttons on your graphing calculator that make working with logarithms pretty fluid. And if you're using those buttons all throughout on your homework, I feel like you should have those on your quiz. So again, we'll talk a little bit more about that tomorrow. Anyway. Yeah, there it is. I was going to say, I know that I printed out the schedule. Pep rally, like you said, is at 10:15. We're going to do shortened period 1, period 2, period 3, then go to pep rally, and then period 4, 5, 6, 7. Period 4 is also shortened, but I think once we hit period 5, 6, and 7 are the exact same as usual. Okay, lunches are the same and all that stuff, but yeah. Third hour gets out at 10:10, 9:30 to 10:10. Pep rally 10:15 to 11:05. If anybody wants to come up and snap a photo of this, that's the schedule for Friday. Okay. All right. So guys, back to this though. Sorry, properties of logarithms. The goals that we have in mind for today: students will be able to rewrite and evaluate logarithmic expressions using the change of base formula. Boy, does that sound wordy. All goes back to we have a formula that is going to help us type in log base 4 of 100, like we had on that previous example. Again, this is like the central focus. How do I calculate what that value is? How do I do it? Some of us have a feature on the calculator that lets us type it in pretty much exactly the way it looks, but everybody else, we're going to have to figure out this change of base formula. Even if you are fortunate enough to have that button on the calculator that does essentially allow you to type it in exactly as you see it up there, it is still important that you know and understand the change of base formula, because there are going to be algebraic problems that have x's, y's, and z's. You're not typing that into a calculator. We have to know all right, this translates to that, okay, which obviously we'll be talking about here very soon. Goal number 2, students be able to expand log expressions using properties of logarithms. And then number 3, students will be able to condense log expressions using properties of logarithms. So before seeing any of these problems, do we have anybody in here just saying expanding and condensing logarithms? Does that ring a bell to anybody? Okay, about half of us with hands up. I'm hoping that the other half can raise their hands once you see the properties. If I'm remembering correctly, in Algebra 2, you worked on expanding them quite a bit. You didn't do much with condensing, but the good news is it's the same rules. We just worked backwards. All right? So here's the deal. On your calculator, and pretty much any calculator, scientific or graphing, you're going to have a log button. That log button, that logarithm, is automatically base 10. You'll also have a natural log button, which of course is automatically base E. So why don't we have a log base 7 button? Why don't we have a log base 3 button? Why don't we have a log base 275 button? It's because we'd have an infinite number of possibilities. That's too many buttons, right? So your calculator has been programmed to where, okay, which is the most common? We even call it the common log. It's base 10. That's the most common one, okay? So because the common logarithms, base 10, and natural logarithms, base e, are used the most frequently, they're programmed in on your calculators. Most calculators are only going to have those two types of log keys. Okay? If you must evaluate a logarithm with another base, we have to use the change of base formula. So, comes in threes here. This first option, gonna level with you, be honest with you, that we're probably not gonna opt to use the first option over here on the left very much, unless it's some sort of an algebraic expression. So what this is saying is log base a of x is equal to log base b of x over log base b of a. Great. What the heck does that mean? Aubrey, give me a number, please. Anything you want. All right, so if we have log base 4 of, Stella, give me another number, please. 18. Perfect, thank you. So if we have log base 4 of 18, what we're saying is that we could rewrite this. Move that over a little bit. I need just a little bit more space. We could rewrite this as, Dallas, give me a number. 2. We could rewrite this as log base 2 of 18 over log base 2 of 4. That this is still true. Now, was Dallas doing some calculations back there and figuring, okay, I'd better say 2 in order to make this work? No, as long as they match, that's going to work. Now, maybe you're already seeing why we would not use this one very much. Where did we get? If the issue was that we couldn't type that into a calculator, how am I going to type these other two into a calculator? But they work, okay? We could call that log base 21 of 18 over log base 21 of 4, as long as we have those common logs. Now, where that is going to be very beneficial is once we start to utilize that base 10. If we went with that same setup that we had the log base 4 of 18 that Aubrey and Stella gave us, what we're claiming now is that if we use base 10, absolutely buttons that we do have on the calculator, could we rewrite this as log base 10 of 18 over log base 10 of 4? Could we do that? Is that going to work out that way? Yeah. Also, do we have the ability to type these into the calculator? Could you figure out log 18 on your calculator? Go ahead and do that real quick. What's log 18, please? Log base 10 of 18. It's a weird decimal, probably. What do we get? Okay. Now, could we divide that by log 4? Yeah, what do we get then? 0.6 something, right? Well, apparently that's what log base 4 of 18 is really equivalent to. Does that make sense, what we're trying to say? Is that we could now do this with the calculator. So, log base 4 of 18. Some students in past years have mixed up. All right, well, which one goes in the numerator, which one goes in the denominator? Because when when you're working with fractions, that matters. And there's a difference between, if we would have accidentally written this as log 4 over log 18, we shouldn't be expecting to get the same answer, right? So again, base is always in the bottom. Base is always in the denominator. As long as we remember that, we're going to be in good shape, okay? So once again, this is the exact answer, but the whole reason for doing this is so we can type into the calculator, we can get to work, okay? Now, if this works in theory for any base, does E work as a base? Yeah, so if we had log base 4 of 18, why not use base E and call that the natural log of 18 over the natural log of 4? I can assure you that we're going to get the exact same answer if we do that, okay? Now, just so we're all on the same page, everybody in agreement that this is not equal to this. It doesn't work like that. This is not equal. This is not the same. Can't say log 18 over log, or natural log 18 over natural log 4. Okay, that's going to be natural log of 9 over 2. Doesn't work like that. We can't reduce within. We can't do that. We actually have to calculate it the way that it says. All right, guys. Once you see this change of base formula, are we feeling pretty decent about that? All right, so if you are using a scientific calculator, this is the way that we're going to have to approach it. Now, some Casio scientific calculators, they'll have a logarithm button that actually looks like this. And you can fill in the boxes. You can go in there and fill in a 4 and go in and fill in an 18 and hit equals, and it's going to give you the answer. That's great. Again, I'd say that you have a slight advantage. It's very slight. It's like it's going to save you 3 or 4 seconds. It's not going to save you 20 minutes or anything like that. It's going to save you a couple seconds to where you can see everything on your screen. Whereas if you're using one of the Texas Instrument brands, you'll have to type it in this way. Okay, I assure you're going to get the same answer. But even if that's what you're bringing to the table, it's very important that you still know and understand this change of base formula. Okay, as soon as we start to throw in variables, are we going to know how to handle that? That's the question. And hopefully the answer is yes. Okay, all right, got an example here. We want to evaluate using the change base formula with common logs. All right, so part A, log base 3 of 16. We set it up as log 16 over log 3. Looks like we've got the common base. If we were to round to 3 decimal places, say, what do we end up with there, please? If you're sitting there waiting for someone else to calculate this, remember, we're doing it wrong. We want everybody to calculate here. Pushing the buttons on that on the calculator. What's log 16 over log 3, please? 2.524. Perfect. Once we round. Okay. What about part B? If we're going to take a look at this next one, log base 5 of 22. What are we going to write that up as? Log 22 over log 5. Okay. Remember, these are base 10 implied. So if we've got log 22 over log 5, what are we going to say that is, please? 1.920. Perfect. Is everybody feeling good about those? Now, what if you had a change of heart and said, no, I don't want to use base 10. I want to use base E. I want to use the natural log. Should we expect that log base 3 of 16 is done this way? Natural log 16 over natural log 3. Should we expect to get the exact same answer? You can check real fast, but yes, we're going to get the exact same answer. If in part B, if we have log base 5 of 22 using the natural logs, natural log 22 over the natural log 5, are we still getting 1.920? Quick check of that. Yes, we're going to get the exact same. Okay, can't stress enough. It really just comes down to which button do you want to push. Do you want to push the logarithm or do you want to push the natural log? Doesn't matter. It doesn't matter. All right, any questions on change of base formula so far? Okay, let's go ahead and try this next round. Oh, I did want to point out, I started talking about calculators and I just get excited about things apparently and I move on really quickly. If you have a graphing calculator, Texas Instrument graphing calculator, I need you to go ahead and find the math button. So the math button, it's all the way on the left. If you were to see the y equals button, so like the extreme top left corner, just go down like 4 buttons. It says math in lowercase letters. Okay, so we've got the math button. By the way, just kind of in a nutshell here, if you're ever looking for anything on your graphing calculator, if you don't know where some feature is, check the math button. Like that's where they hide pretty much everything. So if you hit the math button, you've got all sorts of things. Again, they're numbered, again, fraction, decimal, cubing, cube rooting, x rooting, all that stuff. They're numbered 1 through, those actually to 0. Then it runs out, and then they start using letters. So after 0, they go A and B. So if you were to scroll all the way down to A, if you wanted to go a little bit faster, just scroll up. Hit the up button a couple times. You're going to get to choice A, which is written out this way as log base. So if you were to select this by hitting enter, back on your home screen now, it's going to give you the log fill in the blanks. Okay, you guys see where I'm talking, or what I'm talking about? Okay, maybe you already knew that was there, but maybe you didn't. Now you know. Okay, questions on that? Okay, so whether we're using this feature of the calculator or if we're going change of base, I'm going to write these up as change of base. We've got log base 6 of 9. We all agree that's really log 9 over log 6. Okay, or if we went there directly, what's the decimal, please? Looks like we're going to 3 places. 1.226. What I heard? Okay. What about log 2 of 14? Let's use natural log this time. Natural log 14 over natural log 2. What are we getting as decimal, please? 3.807? 8. That's 8. Everybody, believe it or not, that's 8. 3.807. And then finally, log 1/4 of 12. Got a fraction as a base. That's weird, but it's doable. I don't know. Maybe we'll go log 12 over log 1/4. What are we thinking there as decimal, please? Like 1.792. Am I hearing you right? Okay. All right, guys. How do we feel about these? Pretty great. All right. Next up, we're going to talk about the expanding and condensing. Let me stop this video here.